Hello everyone, welcome to our channel, The Navy Guy. So today we will talk about piston rings. In this video we will talk about, what is piston ring? Types of piston rings. Piston ring material. Life of piston ring. Failures of piston rings. Modern advancements in piston rings. Before getting started, do hit like and subscribe button for much more content. So let's talk about what is piston ring. A piston ring is a metallic split ring that is attached to the outer diameter of a piston in an engine. It provides a seal to combustion chamber, by expanding outwards due to gas pressure acting behind them. They prevent the gases and combustion products passing the piston. It also conducts heat away from piston to liner. It also controls the cylinder oil. There are two types of piston rings attached to piston. First set is of compression rings. Their purpose is to prevent blow-by. They should provide an effective seal of the combustion chamber space. The initial compression of the ring, that is ring tension, puts a radial pressure onto the liner wall. Further sealing is provided by the gas pressure itself entering the back clearance space between the piston and ring. They transfer a large portion of heat from the piston to the cylinder liner, which in turn, has jacket cooling. High piston speeds require less compression rings, since there is a less possibility of blow-by. Now let's talk about second set of rings, that is oil scraper rings. They are rings which eliminate the possible ingress of oil into the combustion chamber. They are fitted lowermost of the rings on the skirt and trunk type pistons. The oil is scraped by the rings whilst the piston goes downwards, and is returned to the crankcase via oil drains in the piston on the upstroke. The rings' beveled side surfaces slide over the oil film without dragging them upwards. The pumping action of the compression rings when the liner bore of trunk-type pistons becomes over-lubricated. When the piston is going down, the piston compression rings are pressed against the upper sides of the ring grooves and oil enters the spaces below the rings. When the piston is traveling upwards, the ring presses upon the lower sides of the ring grooves and oil is forced through the back and upper side clearances towards the combustion chamber. On a short note, let's talk about various clearances of piston rings. Butt clearance. It is the cut that is made in the ring such that due to thermal expansion the ring doesn't collapse. It has high importance because 1. If all the butts get aligned, the combustion gases blow-by or blow-past takes place, which might lead to scavenge fire. 2. If the butt clearances of any piston ring decrease, the ring might collapse and not seal the gases. Axial clearance. It is the vertical distance between piston ring and piston ring groove. It is also of high importance because 1. It allows pressure to build up behind the ring. 2. It allows oil to flow into the groove. 3. It allows pressure to build up behind the ring. Back clearance. It is the horizontal distance between piston ring and piston ring groove. Now let's watch a video regarding checking of piston rings when decarbing a piston.
Butt clearance is also known as ring end clearance or gap clearance. It is the distance between the connecting faces of piston ring. This clearance should be within the limits specified by the engine manufacturer. The ring expands when the engine is hot. If the clearance is less than the minimum limit, the ends touch due to this thermal expansion. The ring expands against the liner. This increases the friction, resulting in breakage of ring and seizure of piston. If the clearance is greater than the maximum limit, combustion gases blow by the rings and exhaust gases enter the crankcase. This results in loss of compression pressure in the cylinder. To measure butt clearance, insert the rings in the bottom of the liner and ensure that they are in line with the linear axis. Measure the clearance between the faces of the piston ring using a feeler gauge. Record two sets of readings, forward, aft and port starboard. Axial clearance is the clearance from the top of the ring to the top of ring groove. The combustion gases exert pressure behind the piston rings and push towards the liner for proper sealing. If the clearance is less than the minimum limit, combustion gases cannot flow behind the rings. To measure axial clearance, fit the ring in the respective groove such that it rests on lower surface of the groove. Measure the clearance between piston ring and upper surface of the groove using a feeler gauge. Record two sets of reading, forward, aft and port starboard. Back clearance is the clearance from inner diameter of the piston ring to inside diameter of the groove. Thickness of the ring should be less than the groove depth, so that the outer ring face is inside the ring groove. If there is no back clearance, the rings take the side thrust. This results in high friction and possible piston seizure. To measure back clearance, measure the depth of the piston ring groove by means of the depth gauge. Use vernier caliper to measure the thickness of ring. Take both these measurements in at least 6 different positions around the groove circumference. The difference between the two readings will give the back clearance. If the back clearance is more than the specified limit, replace the rings.
Before dismantling the piston rings, measure the free ring gap of all the piston rings. Take off the piston rings by means of the ring expander. Clean and inspect the rings and measure the radial width of the rings. Note down the results. See the instruction book, Volume 1, Chapter 707. Clean the piston crown. Check the ring grooves. The maximum vertical height in a worn ring groove must not exceed the value stated in the datasheet. Check the burn-away by means of the template. The maximum permissible burn-away value, see datasheet 1021. Mount the piston rings with the top mark upwards and the ring gap staggered 180 degrees.
Now let's talk about piston ring material. The piston ring is made of cast iron. Gray cast iron gives better wear and scuffing resistance. Nodular chromium-plated malleable cast iron gives better fatigue resistance. Carbidic malleable cast iron gives better fatigue and wear resistance. It is provided with RVK with Al bronze as a running and coating. If we talk about life of piston rings, that is wear rate of piston rings. Ring wear rate, around 0.1 mm per 1000 hours, depends on fouling of the turbocharger, reduced scavenge air pressure due to more dirt in the ring pack area, overloaded engines or excessive pressure rise, poor clearances, poor fuel injection or poor fuel quality, poor lubrication, poor water shedding in scavenge air which produces water drops on the cylinder liner affecting lubrication and causing scuffing, poor maintenance of grooves or incorrect fitting of rings. Let's talk about piston ring failures. Collapse. It is the collapse, inward push of the ring against the piston body due to gas pressure buildup against the running face of the ring. It is caused by the pressure buildup against ring running face and liner wall due to reduced axial clearance, poor ring and groove sealing, rings not free to move in the groove, or poor lubrication on sealing surfaces. Flutter. Flutter is the oscillation movement of the piston ring along its own plane. It is caused by a radially worn ring leading to a reduction in radial areas, or pounding of piston rings in the grooves when the piston changes its direction. Excess wear. This is due to poor clearances, corrosion, abrasion, scuffing or improper lubrication. Jammed or sticking piston rings. This is due to the buildup of carbon deposits or poor clearances. Scuffing. It is the overall damage on the sliding contact surfaces, caused by the formation of local welds. These welds occur due to high local temperature, 800 degrees C+, which hardens the base metal, forming hardened particles at that point. Now let's talk about modern advancements in piston rings. Controlled pressure relief, CPR, rings. In CPR type, the topmost ring has 1 double lapse seal and 6 controlled pressure relief grooves cut across the face. This ensures even pressure distribution and decrease of thermal load to the second piston ring as well as the liner. Other piston rings have an al bronze coating and oblique cuts. Piston cleaning ring, MAN B&W. Anti-polishing ring, Wärtsilä. It is a ring embedded in the top edge of the liner just below the cylinder head level. Its inner diameter is slightly lesser than that of the cylinder liner, thereby scraping off the carbon deposits at the top land portion, which would otherwise contaminate and affect optimized lubrication. It also reduces the polished effect of the liner wall, which gets formed due to the hard combustion deposits coming in contact with the liner. SIPWA, Sulzer's Integrated Piston Wear Analysis. It is a method using a continuous online feedback measurement of the piston ring wear condition. The piston ring has incorporated a wear band. As wear down of the piston ring takes place, corresponding wear down of the copper wear band takes place. A sensor in the cylinder liner senses the wear of the copper wear band and transmits this signal to an online electronic unit, which records and prints any wear down, which can be used as a pre-warning. So that's all for this video. If you liked our video, do share it and subscribe our channel for more videos. Also follow us on Instagram and Facebook for exclusive content. Hail the sale!